You're staring at a geometry exam. You plug the numbers into the formula, and the marks still don't come through. For cone problems, that usually happens because the wrong height was substituted into the equation. In the next 5 minutes, we'll build a reference sheet covering volume, surface area, and the specific steps required to recover dimensions that examiners often hide. Grab a scientific calculator, a pen, and a blank piece of paper. You'll want to map this out as we go. Having these steps pre-calculated in your mind turns the pressure of an exam into a mechanical, repeatable process. Draw a cone. The perpendicular height, h, drops down the center. The slant height, L, runs along the edge. Radius r connects the center to the edge, meeting at a right angle. Notice, volume requires straight height, h. Surface area requires slant height, L. Visually distinguishing between the vertical path and the slanted edge prevents the substitution errors that derail most cone problems. This diagram from question 1 provides a radius of 5 centimeters and a perpendicular height of 9 centimeters. To find volume, use the formula 1/3 pi r squared h. Substitute 5 for the radius, 9 for the height. On your calculator, use the fraction button for 1/3, then multiply by pi, 5 squared, and 9. This handwritten line shows the calculator's exact output, 75 pi. Exam questions frequently ask for this in terms of pi format to see the unrounded value. Using the S to D conversion button gives us the standard decimal answer, 235.6 cubic centimeters. Always check the specific question wording before moving on. Providing the decimal when they asked for the pi format can cost a final mark. In this next example, we have 3 dimensions, a radius of 3, a straight height of 4, and a slant height of 5. Total surface area has 2 parts. Pi RL is the curved outer surface. Pi r squared is the flat base. This choice matters. For the curved area, use the slant height. Select the 5 from the edge. Ignore the straight height. The workings show the breakdown. Curved area is pi times 3 times 5, or 15 pi. The base is pi times 3 squared, giving 9 pi. Adding those gives an exact area of 24 pi, or 75.4 square centimeters. Treating the surface area as 2 separate objects ensures the base isn't forgotten when the question asks for total area. Some problems omit required dimensions. In question 12, we have the radius and slant height, but the perpendicular height needed for the volume is missing. We solve this by extracting the right-angle triangle from inside the cone. The radius is the base, the slant height is the hypotenuse, and the perpendicular height is our unknown side. Using Pythagoras, we set up the equation. 5 squared plus h squared equals 13 squared. Following the steps, 25 plus h squared equals 169. Subtracting 25 leaves h squared at 144, so our perpendicular height is 12. Mastering this triangle extraction allows you to solve high-value problems even when necessary numbers are deliberately hidden. You now have a complete reference for managing cone calculations under exam conditions. Pause the video here to verify your own notes against this finalized sheet. Ensure you have the anatomy, both formulas, and the Pythagoras fix recorded. These same steps apply when cones are part of compound shapes, like those stacked on cylinders. Use these tools on your next practice paper to solidify the process.